4-45. Examine the graph of each relation below. For each part below, decide if the relation is a function, and then state the domain and range. This one shouldn't take us very long. Let's take a peek. So letter A. We have this very beautiful diagram here, this graph, and it kind of looks like a nice flower. And you'll see here that if we pick out any input value, let's say, oh, I don't know, 2. So for the input of 2, or when x is 2, you notice that we have more than one output value. So right away, we know here then if any input has more than one output, this relation is not a function because of that. So we could say this relation is not a function. Remember, for each input there would be exactly one output. In this case there was 2. There was 2 for many of these here. There were more for some of them as well. Now let's look at our domain. Remember, domain is talking about our values of our inputs, our x's here, all the possible ones we could have. So in this case, we want to look to see how many boundaries do we have, because there is no broken areas. It's pretty solid from one end to the other, but we have a boundary point here and we have a boundary point here. So if we have 2 boundary points, that means we're going to have 2 inequalities. So if we think about from here going in this way would be like one inequality, and from here going this way would be another inequality. So we look at that there. We could say that x is going to be greater than or equal to -3. And remember, if you're writing 2 inequalities, you have to put and in between. X is going to be less than or equal to 3. So for those of you who would prefer writing it as as one statement there without 2 inequalities, you could write it as a compound inequality. You'd want to say, well, our left side we have -3. I'm just more or less taking this and flipping it around. So I have -3. Remember, our inequality is pointing towards it, so -3 is less than or equal to x, and x is also less than or equal to 3. So either one of these would be perfectly acceptable for your domain. For range, same kind of things going on here. It goes down to -3, so there's one boundary point. So it's going to be greater than or equal to -3. And then we have a top point here. So we can describe that using an inequality. So 2 boundary points, 2 inequalities here. We're going to say y is going to be greater than or equal to -3, and y is less than or equal to +3. So that's writing it as 2 inequalities, or you can take it and combine them into one. Just flip this one around. -3 is less than or equal to y, which is less than or equal to 3. So there's our range for part A on 4-45. Let's go ahead and talk about B here. So domain and range. Well, first of all, is this a function? Well, as we look at each point on this relation, you'll see here that every input value has only one output value. So we could say that this relation is a function. So it is a function. Now we want to discuss the domain and range. So as we look here, there are no breaks in it. So we know our lowest input value would be at -2. So it looks like we have one at -2. And if that's the lowest, it's going this way. And then we have a highest input value at 3. So 2 boundary points means 2 inequalities. So we're going to say here that x is going to be greater than or equal to -2, and x is going to be less than or equal to 3. I'm going to write it as that compound inequality. Just flip this one around. -2 is less than or equal to x, which is less than or equal to 3. Range, we're going to be looking for the lowest point on the graph is right here. So that's where y is -2. So that's our lowest point. And our highest point is up here. So remember, it doesn't always have to be the end point. It's just our highest point, which is right here. So it goes from here down. So we're going to say y has got to be greater than or equal to -2. And y is less than or equal to +2. And one last time, let's take it and change that into one statement. So we have -2 is less than or equal to y, which is less than or equal to +2. That's pretty much it for 4-45. We have problem A and problem B, just a little domain and range there. If you have questions, make sure you ask your teacher or find help from somebody. This is Mr. Boyd signing off. Beep boop boop bop bip bip bidoo bidoo. Yeah.